Okay, last I left off, we found that this equation right here was the equation of a line that goes from this point to this point, right? And actually goes a lot further than that, extends beyond that, but I only care about it from 0 to h, right? And the reason I care about that line is because the distance from the axis x to that line, right? If I take each one of these points, an infinite number of points, and I flip it around the x-axis, right? Maybe I'll make that in red so I can see it. Flip it around the x-axis a bunch of times, right? That becomes the radius of a circle. So this equation is the radius, which I'm going to use in my area formula of a circle, pi r squared. And what I'm going to do is add up all those circles, right? Add up each one of these circles until I get a nice, beautiful cone. Right, and that's the goal here. That's the point. Add up all those circles, I'll get the volume of a cone. Okay. So I'm going from a 2D shape over to a 3D shape. Right? I'm taking 2D and I'm multiplying it by its linear thing, and I'm turning it into another dimension, 3D. Okay. So then this becomes my new function that I'm going to integrate from 0 to h of pi r squared dx, and that's how I add up all those circles. I integrate, and written out again, that becomes 0 to h of pi times my new r. This is my new r right here, times negative r over h x plus r, that whole part squared dx. And what I'm going to do is I'm going to take this function and I'm going to expand it out so it looks a little bit nicer before I move on. So I have negative r over hx plus r squared, and this is just binomial, so it becomes r over h, or r squared over h squared times x squared minus two of these. So I'm going to multiply this times this and this times this, and I'm going to get 2r squared over h times x. And I'm going to multiply this twice, and I get r squared. Okay, so that's the function I'm going to integrate over. All right, so let me rewrite that. I'll rewrite that in purple here. And I get the integral from 0 to h. And I'm just going to do something wild. I'm going to put out my pi right out here, okay? Because when I multiply pi from the inside to the outside, it doesn't change the equation at all, okay? So then it becomes the integral of pi times r squared, which we found out was this guy, r squared over h squared times x squared minus 2r squared over h times x plus r squared, all of that dx, okay? Make my x's obvious to you. And the rest, these things are just coefficients, right? Okay. So, what does that become? Well, this is going to become x cubed over 3, this guy's going to become x squared over 2, and this guy's just going to become x. Now, what is the coefficient of each of those? Doesn't change. It's r squared over h squared minus 2r squared over h plus r squared. All of that evaluated from 0 to h. I'm going to multiply all of it, though, by pi. I can't forget that. Alright, so when it looks like each one of these functions has an x right there, that one, and that guy, they all have x's in them. So this 0 right here isn't going to really do anything to it. So the only thing that's going to change it is the h. So I'm going to plug the h in for the x's, and let's see what I get. R squared over h squared times h cubed over 3 minus 2r squared h squared over 2h plus r squared h. These 2's cancel out. This h cancels with this h. This 2h's cancel with that guy. This looks like negative, so this becomes negative r squared h plus r squared h. Those cancel out, and the only thing I'm left with is the r squared h over 3 times pi, which simplifies to 1/3 pi r squared h. And that's the volume of a cone.